It's recording. All you gotta do is hold it.
So when you're done, you hold me again?
Just hold it just like that. Okay. Just hold both hands. Don't.
I'm here to talk to you about the chemistry program and my science fair project. So we've been doing chemistry at ESCO for about 2 years, and it's a great program. Chemistry just helped me with so much stuff. It helped me learn a lot of chemistry. So I encourage anybody who has kids to let them come in and enroll in chemistry and let them join in. And also, chemistry also helped me a lot with my science fair project. For my science fair project, I won 2nd place at Coriel, 2nd place at Delaware Valley, and I won other special awards, including the ESCO award. So here's a video of me winning at Delaware Valley.
In the chemistry category, honorable mention, Patrick Powers, Bishop McHugh Regional Catholic School. Honorable mention, Katie Dent, William Allen Middle School. Honorable mention, Laura Olson, Andrew Christian School. Honorable mention, Drew Spanfelder, Downtown Middle School. And no one noticed, Jewish Day School of Lehigh Valley. 3rd place, Catherine Shue, Holland Middle School. 2nd place, Jacob Bauldock, Cancer Chemistry. In middle school, I must add, we do have a lot of honorable mentions, but there were almost every category had at least 25 projects, some had over 30. So there were placing. And even if you got an honorable mention, it's a significant accomplishment. To be proud. In the computer science category, honorable mention, Josiah Eisenberg.
So yeah, and also chemistry is also about it goes over these topics. The first 20 atoms with the periodic table, ions, acids and bases, oxidation and reduction, organic chemistry, and takes you all the way up to electrochemistry, which is actually what my project was based off of, which is the efficiency of a split cell reactor over a single cell reactor. Now, some of you may be wondering what a single cell reactor is. Well, there we go. So basically, you could just use like a regular cup or something like that. And here's the split cell reactor, which you can tell the difference, obviously. So now let me go over, and also here are my results. This, actually, I kind of did use that. I did use Logan Township actually. Yeah. So, the current that is high, or it doesn't last very long, is the current of a single cell reactor. But the current that lasts long, it doesn't go very long, is the current of a split cell reactor. And I'll explain why one's higher and one lasts longer later. So now I'll go over the electrolysis of a sodium chloride solution. First, you have sodium chloride, which is regular table salt that you put on your French fries and whatnot. So you start out with the atom sodium, number 11 on the periodic table, and chlorine, number 17 on the periodic table. Now these two atoms came together because they had lonely electrons, so they decided to share one, and it came together to form sodium chloride. When you put this molecule in water, they have a tug of war for the electron. And chlorine wins because it has stronger electronegativity than sodium. The electronegativity is the strength of an atom to take another atom away, to take another electron away from another atom. So when the chlorine takes away the electron, it now becomes a chloride ion. Now an ion is anything that has a positive or a negative charge. Chloride has a negative charge because it has more electrons, which has a negative charge, than protons, which have a positive charge. Sodium now becomes sodium plus because it has more protons than electrons. So in the cell, there are two wires, the positive wire and the negative wire. Since opposite charges attract each other, the negative chloride goes to the positive wire, and the sodium plus goes to the negative wire. When the chloride ion electron touches the positive wire, it loses its electron, or it's been oxidized, which is when an atom donates an to have it to live. So water behaves in a strange way. That proton right there keeps on jumping on and off and on and off of this atom, this molecule right here. When it jumps off, it leaves behind the hydroxide ion, which is another negative ion. And then when it jumps back on, it just becomes water again. So when this electron comes down, it jumps onto the proton to create hydrogen, the first atom on the periodic table. It doesn't jump on the sodium though, because the proton has a stronger electronegativity than the sodium and the hydroxide ion. So in the cell, there are obviously more hydrogen atoms in there. So these two hydrogen atoms come together and form hydrogen gas, and then they bubble out because gases bubble out of liquids. Chlorine does the same thing. They come together, form chlorine gas, and then they bubble out. Sodium and hydroxide ions stay in the water, and they form a sodium hydroxide solution, which is a basic solution. Now, here's the downside to the single-cell reactor. All these positive sodiums start to collect up near the negative wire, that the chloride ion gets confused whether to go to all those positive sodiums or the positive wire. That's why I thought at first that the split-cell reactor was more efficient. Because now everything is the same except for a few things. Now the sodium has to travel through the agar salt bridge to get to the cathode cell, which is the negative cell. I made the agar salt bridge out of water, agar, and salt basically. It forms a gel-like substance. So now the sodium has to migrate through and it starts to accumulate over here. And the chloride doesn't get confused whether to go over here or over on the anode side. It knows to go to the positive wire. And the same thing happens again. The electron goes up through the battery, through the ammeter, back down to the water, and then the proton, the chlorine, So here are my results. Like I said before, these these currents up here that are high, but they don't last very long, are the current of a single-cell reactor, and these current two lines represent the current of a split-cell reactor. Now this is higher because, well, it's quicker. Like the sodium doesn't have to travel through an agar salt bridge, so it's quicker, and the sodium just right away goes to the negative wire.